So today we're going to look at Rady Worksheet 1. So we've already done the basics. Worksheet 0 that you guys did last time, that was just the very basic type rational function you're going to get. These are more, I don't want to say complicated, but they're more fun, I'll say that. So for Rady Worksheet 1, I would definitely recommend having your Rady steps next to you because we are going to use these to help solve the problems that we're going to do on this page. We're going to start with the very first question. So for question 1, this is pretty much the same that you've seen on Rady Worksheet 0, but I just want to use this to kind of review what you've already seen. So Enya, what does the R stand for in Rady? Roots. And what does that mean when you're locating your roots? How do you find them? Set your numerator equal to 0. So let's go ahead and do that. So I'm going to take the x, set it equal to 0, and normally I would solve, but if x is equal to 0, it's already solved. So that's my x. It's just x equals 0. Let me box that. X is equal to 0. Okay, the next thing I need to find is the a, which is your vertical asymptote. Enya, how do I find the vertical asymptote? Set your denominator equal to 0. I'm going to make one little note here. Make sure you write your vertical asymptote as an equation. If I don't see it as an equation, guys, I can't give you full credit. So we're going to take x minus 5, set that equal to 0, and solve. So we'll just add 5 to each side. So x will equal 5. This is your vertical asymptote. Next part, Enya, how do I determine the tangent? What do I need to look at? The multiplicity, specifically where? Numerator or denominator? Denominator. We're looking in your denominator to check to see if it has a multiplicity of 2. So remember, guys, these are examples of multiplicities of 2's. These are not examples of multiplicities of 2's. So, Enya, for this question, x minus 5, what's the multiplicity? Is it 1 or 2? It's 1. Since we have, I'll tell you for sure if we have multiplicities of 3's, that's definitely like what we saw for polynomial functions, but this is just a basic multiplicity of 1. This whole binomial is raised to the first power, and I did the same thing on our Rady worksheet. Anytime you just have a binomial with no exponent, just put it in parentheses and raise it to the first power. That will be your multiplicity. Okay, the next part is E for your end behavior. Caitlin, how do I determine my end behavior? What do I need to look at?
The ratio of the first term.
Okay, we do need to look at the ratio of the first terms, but we need to do something before that.
On the
Degrees. Degree of your numerator and degree of your denominator. So in this numerator, what's the degree?
1.
And what's the degree for your denominator?
1.
Also 1. Keep in mind, guys, degrees and like the degree that you're looking at for your end behavior and the multiplicity are technically two different things. Most of the time, they'll be the same number, or the same representation. Multiplicity and degree will be the same, but not always. So don't think that they're both just the same. I'm sorry to deviate from that. But Caitlin, since it's a degree of 1 over 1, what does that mean down here?
Y equals 1.
Okay, well, how'd you get y equals 1? Because I didn't see that down here. First, is it balanced or bottom heavy?
Balanced.
It's balanced because your degree and your numerator and denominator are the same. So I'm just going to make a little note. This is balanced. And we're going to write out our ratio like you told me before. You're going to check the first terms as your ratio. So we're going to take this first term, which is just x, and we're going to divide it by this first term here, which is just x. That's how you got your degree. Your degree came from this exponent and this exponent. So Caitlin, go ahead and simplify that. What's x over x?
1.
Just 1. That's how you're going to get that y equals 1, guys. Don't just take the degree that you have. Actually use that x over x, whatever your coefficients are for your variables. Specifically, your leading term, your leading highest exponent. And then the last part is your y-intercept. Caitlin, how do I find the y-intercept?
Plug in 0 for x.
Plug in 0 for x. So we'll have 0 over negative 5, and then 0 divided by negative 5 is just 0. This is your y-intercept. So let's take all of this information and plot it on my graph. I'm going to first start with my y-intercept, which is at the origin, or excuse me, the x-intercept, which is the origin. My vertical asymptote is at positive 5, so 1, 2, 3, 4, 5. Here's my vertical asymptote. And I want to make a note here that with that multiplicity of 1, oh, I'm sorry, I forgot to ask Enya. You guys help me out, though. With that multiplicity of 1, what does that mean? Is it graphed together or apart? It's graphed apart. We're going to graph it in 2 separate directions. Forgot about that. My end behavior is at y equals 1. So let me graph that out. Here's 1. So y equals 1 will just be this line. And then my y-intercept is also at 0. If you look at the y-axis, guys, your y-intercept is already graphed. It's the origin. So I have everything I need. If you think back to what we did when we were graphing these last time, I told you guys if you have a point, that's pretty much gold. That's exactly what you want. So especially, this is what we did last class, the very first question. We graphed it because we had our point and we had it go towards your asymptotes. So we're going to do the same thing here. We have our point and we're going to have it go towards this asymptote and this asymptote. Michelle, what does that mean if it's going towards the asymptotes? Why can't I cross that line? You say it one more time. It approaches the asymptote. Doesn't actually touch, but it's going to get very, very close to it. It's just going to approach. Okay, with that in mind, we now need to graph the other side. So it should be at the diagonal, but I want you guys to keep in mind, we're just graphing the other side of this image right across this vertical asymptote. So we just need to graph it on the other side of our vertical asymptote in one of these 2 quadrants. Well, as you're approaching this function, you want to make sure that you graph it apart. We talked about this. If you're seeing somebody in the hallway you don't like, you're not going to follow them and talk with them. You're going to go in the opposite direction. So the same thing's going to happen here. If you're graphing it apart, it's going to go in this upper quadrant right up here and get very, very close to those asymptotes, but it will never actually touch. I want to do one other thing before we move on, and that's going to be discussing your end behavior. I want to look at 2 end behaviors. As x approaches infinity, that is an infinity, f of x will approach something. And as x approaches negative infinity, where's f of x going to approach? Keep in mind, guys, you should have learned this back in Algebra 1. F of x and y are the exact same thing. So when I say y or f of x, I'm just talking about the y values. Yes. Say it one more time. Well, let's see. So as we are doing x approaches positive infinity, this graph is going to be going to the right as it approaches positive infinity. What's happening to this blue part of the curve, Brooks? What is it getting close to? It's getting close to 1. So right here, I'm just going to put a 1. That's exactly right. It might not always be the same on the other side, so let's check. As x approaches negative infinity, Brooks, where is it approaching? 1. The curve, this blue curve, which is your function for y, is going to get closer and closer to 1. That's it. That's all you're doing for your end behavior. Give me a nod or shake. Is this okay? Does this refresh your memory a bit? All right, perfect. Let's look at the next question. Not number 2, but number 3. Remember, there's methods to my madness. All right, let's look at question number 3. Take a second and look at it. See what we're going to get. All right, so for question 3, first thing I need to do is look for my roots. Lorraine, how do I identify my roots again? What do I need to look at? The numerator. In this numerator, do you have a variable? No. So even if you tried to set negative 4 equal to 0, can you solve that? So that means there's what? No roots. There's no x-intercepts, no roots, none, if you want to write that. There are no x-intercepts, no roots, or none. How do I find the vertical asymptote, Lorraine? Okay, well, this is different. We now have a squared in the denominator. What I do not want you guys to do is FOIL this out. Don't FOIL it. What we could do is we can actually solve this equation. Some teachers will just say, oh, just take the x plus 3 and solve. But honestly, guys, by having this x plus 3 squared equal to 0, I'm not changing anything. Think about it. What's the opposite of squaring? Square rooting. So we're just going to square root this side and square root this side. We're going to have x plus 3 equal to, what's the square root of 0? 0. It's not changing anything. So that's what I'm saying. I don't mind you guys solving because it's not going to change your final answer. All right, from here, we're just going to subtract 3 on each side. So x will equal negative 3. That is my vertical asymptote. I'm trying to keep the radi stuff together, but I might start needing to use the back page. Chris, based on the tangent part, we know we need to look in the denominator. Keep in mind, if your multiplicity is 2, it's going to look like these examples here. What do you think your multiplicity is down here? 2. We do have a multiplicity of 2, which means that your togetherness or apart, depending on how you're going to graph it, it's going to have to be together. So we're going to have to graph this together, and I'll show you guys how that's going to look. Chris, what does E stand for again? I forgot. End behavior. So when we're looking at the end behavior, what do we need to look at again? The degree of your numerator and denominator. So for the end behavior, guys, I'm going to kind of scratch out my Y because I need the extra space. For the end behavior, we're going to look at the degree of our numerator and the degree of your denominator. In your numerator, Chris, what's the degree? 0. And what about the degree for your denominator? I will say this, be careful. The multiplicity and the degree are not always the same. If you were to FOIL this out and do x plus 3 times x plus 3, what would be the highest exponent you get when you FOIL it? Say it again. 2. It would be x squared. So that's going to be your degree. Some of the time, and I don't want to say most, but some of the time your degree and your multiplicity will be the same, but that won't always be the case. Is that okay? All right, cool. So because of that, we have 0 over 2. Okay, that's not what Caitlin told us on the last one. It's not balanced. It's now bottom heavy. Chris, when it's bottom heavy, what's your horizontal asymptote? Nope, not 0. Look up, Chris. Y equals, you guys know I'm going to take off points. This is bottom heavy, which means your horizontal asymptote is Y equals 0. Even though I crossed out the Y, we're still going to find the Y-intercept, and Caitlin told us this on the last question. You're going to plug in 0 for X. So we're going to have negative 4 over 3 squared, and 3 squared is just 9. It is okay that you don't have a calculator. You can still graph this. So I want you to go ahead and take your pencil, and I want you to start plotting the things that you know. All right, let's start seeing what we have. We have no x-intercepts, which is nice. We have x equals negative 3, 1, 2, 3. That's my vertical asymptote. And I'm going to label this together. We have end behavior is at y equals 0. So that's along the y or x-axis. And then we have a y-intercept at negative 4 over 9. Okay, negative means it needs to be below the x-axis. 4 over 9, I know 9 over 9 is 1. 4 over 9 is going to be probably in the middle somewhere, so maybe a little bit above the middle. There we go. That's what we have so far. Okay, so the first thing that I think we can all do together is create the curve that's going to be in this bottom quadrant here. So it's just going to look something like this, and it's going to get closer and closer. I'm not making it level. I'm trying to get it closer without actually crossing that line. Okay, now it's together. So take a look up here. No matter what, the other part of this curve has got to be on the other side of this vertical asymptote, for sure. It's either going to be in this quadrant or this one. Okay, so we need to think together. The ones that we were doing with apart, that was when you were avoiding somebody in the hallway. Together is when you're like seeing your friend in the hallway and you're like, hey, how's it going? You don't want to go to Miss Tapia's class. Let's go the other way. So that's what you guys do. So on this side, let's think. If you're approaching your friend, are you going to try to avoid them or are you going to go with them? You're going to go with them. So you're going to go down in the same direction. So should I graph this in the first area or the second? In the second. You're going to start down here and literally just go right with your friend. And y'all going to be walking together, skipping my class and being like, oh, we don't want to go to Miss Tapia's class and learn math. Yeah, I made a whole backstory. Either way. So this is going to be your graph. Keep in mind, whenever you're doing together, guys, please don't put it on the same side of your vertical asymptote. You need to have one on the right side and one on the left side. One part of your curve on either side. Give me a nod or shake. Is this okay? Okay, cool. Let's talk about the end behavior. So we're going to look at x approaches infinity again. What is f of x doing? And x approaches negative infinity. What is f of x doing? Don't yell it out. Write it down. Elias, be careful. As x approaches positive infinity, so as this graph continues to the right, where is this purple line going to approach? 0. And as x approaches negative infinity, so as the curve continues to go to the left-hand side, where's this curve going to approach? 0. Just because both of these are going down the y-axis, guys, that's not going to be going towards positive and negative infinity. When we start changing stuff toward, or looking at the end behavior towards the middle vertical asymptote, we'll talk about what that looks like. All right, let's go ahead and look at the next question we're going to do, which is number 7. There's methods to my madness. It's on the last page of this packet. So let's go ahead and flip it over. All right, question 7, ew. All right, wasn't expecting that. This denominator. Let's see if we can try to simplify this a bit because, and this is a reason why I'm kind of starting with looking at this to see if I could simplify, if you look up for just a second. When we start talking about multiplicities and all that stuff, I don't want to see a polynomial like this because it's going to mean that it's probably going to have a multiplicity that's apart. And who knows, it might have a multiplicity that's apart. There's 2 reasons why I'm doing this. I want to see if anything's being squared like this, and I also want to be able to determine what your end behavior is going to look like. This will be helpful if you actually factor this denominator. So let me draw my little X chart, and I need to find 2 numbers that will multiply to positive 9 but add up to negative 6. What 2 numbers can I use? Negative 3 and negative 3. Perfect. Okay, so let's rewrite the binomial for the denominator. Let me double check before I do this, though. Is your leading coefficient a 1? Yeah, the number in front of x squared, which is the highest exponent, is a 1. So let's rewrite it. We're going to make this x minus 3 and x minus 3. Tristan, what do you notice about that denominator? What do you notice about that denominator? We're looking at these 2. What do you mean you could put them together? Okay, so tell me what to write. Plus 3 or minus? Minus 3, and you want to square it. Perfect, we can do that. So instead of rewriting them as 2 binomials, just write it as one big one. That means I'm going to focus on using this equation to simplify instead of the original. Especially as we start going through other types of questions, you're going to see when that original question is no longer helpful. Only the simplified equation is. So now that you have this simplified equation, we've kind of had this discussion on it, I want you guys to try to do the whole radi bit and the graph. See if you can do the whole part here for question 7. All right, let's see. For the R, for radi, these are your roots. Andrea, what's the roots here? None. There are no roots. Perfect. For your vertical asymptote, what are your roots? Or excuse me, what are the vertical asymptotes? Give me the equations. Or equation. X equals negative 3? Not quite. If you were to take, let's think about what we have. If we were to take x minus 3 squared, set that equal to 0, first thing you would have to do is get rid of the squared. What's the opposite of squaring? It's okay. What's the opposite of squaring, though? Okay, so this is going to make it x minus 3 equals 0, and then you're just going to add 3 to each side. You're okay. It's common mistakes. The only thing that I'm worried about is this denominator is now squared. What does that mean about your multiplicity, Andrea? What is that going to be? Your multiplicity is 2, which means it's what? Together. Perfect. E is your end behavior. So for your degree for this, guys, be careful. Your degree in your numerator for the new problem is 0. There's no exponent up here, or no exponent, no variable. The degree for your denominator is going to be if you were to FOIL this out, because technically what I could make you guys do is actually FOIL this out to see what it would look like. But I know what you're going to get on the next couple of packets, and I don't want you guys to lose interest in math completely. Whenever you have this, if you were to distribute this and actually multiply it, your highest exponent would be what? It would just be a 2. It's ironically the exact same thing as your multiplicity. That will not always be the case. This number will not always correlate to its degree. Just keep that in mind. If you were to actually FOIL out that binomial, you get this guy here. So it's going to be a 2. That's going to mean it's bottom heavy, which means your horizontal asymptote is y equals 0. Carol, what's the y-intercept here? What's your y-intercept? 5/9. Is that positive or negative? Positive. So let's graph what we have. Thank you, ma'am. We have no roots. we have x equals 3 for our vertical asymptote. And I'm going to make this together when I graph it. Hopefully I spelled together right. Looks wrong. Your end behavior is y equals 0. Uh-oh, I'm hearing some exhales. Okay. 5/9. Is that bigger or smaller than 1? Smaller. So I'm going to put my y-intercept. Here's 1. I'm going to put it right about here. It's a little bit bigger than 4/9, so we're just going to put it a little bit above halfway. All right, so let's think about the curve. If I look in this top quadrant here, this is the only point I have. So I'm going to kind of curve this up this way. I'm going to curve this going down that way. If I was going to make this together, for sure, you cannot use this little quadrant down here. You cannot use it. You have to use either this quadrant up here or this quadrant down here. Maria, should I use the first or second quadrant to graph this? First one. And when you graph it, am I going to make it go down or go up? Go up. It needs to go up in this direction and then curve to the left, or excuse me, to the right. This would be your graph, guys. Please don't make this more difficult than what it has to be. Before we talk about the end behavior, are there any questions? Let's talk about the end behavior. We have 2 last questions to do, and then we'll be done. Elizabeth, as x approaches positive infinity, so as this curve continues to go to the right-hand side, where are these y values getting close to? 0. And then as x approaches negative infinity to the left over here, where's your blue curve going to approach? 0 as well. That's it. All right, let's look at question 8. There's a reason why I didn't have you guys just dive into question 8, and it has to deal specifically with the graphing. So let's talk about what you're going to look for in question 8. Okay, for question 8, I'm going to move this over, and we're going to look at the steps for radii. Okay, first, trinomial in your denominator. Let's see if you can factor it. So I'm going to make my little x chart. I need to find 2 numbers that multiply to -6 but add up to -1. Which 2 numbers can I use? -2 or -3? -3, +2. When I multiply them, I'll get -6. When I add them, I'll get -1. So let me rewrite my denominator. We're now going to have 3 over x minus 3 and x plus 2. This looks a little different. Can I rewrite this denominator squared like I did on the last question? No, they're 2 completely different binomials, so you cannot rewrite them as one big one. I'm still going to cross out the original, even though this isn't equal to y. It should have a y equals here, but it doesn't. So y equals in front of this fraction, it's not going to change anything. We still have to factor. Either way, this is what we're graphing. Okay, so this is our simplified form. Let's start with our roots. Nicholas, are we going to have any roots here? No, there's not going to be any roots. For our vertical asymptote, what do I need to set equal to 0? For our vertical asymptote, Nicholas, the denominator. So we're going to take x minus 3 and x plus 2 and set that equal to 0. How many things are we going to really need to set equal to 0 here, Nicholas? 2 things. We're going to set that x minus 3 equal to 0 and the x plus 2 equal to 0. That means there's going to be 2 vertical asymptotes, guys. So we're going to add 3 to each side. So x is going to equal 3. And then we're going to subtract 2 on each side. So x will equal -2. Nicholas, looking in your denominator, just focus on the x minus 3. What's the multiplicity there if you don't see it? It's a 1. So does that mean you're going to graph this x equals 3? Are we going to graph this together or apart? Apart. Notice how I'm just focusing on each binomial. I'm not doing both of them together. For the second one, for x equals 2, we had the x plus 2 that we referenced it. What's the multiplicity here? 1 again. So where are we going to graph this one? Also apart. The direction for this will also be apart. Keep in mind, guys, multiplicity and degrees are a little different. They're not the exact same thing every time. When I'm looking at the end behavior, I'm going to write this to the side since I'm running out of space. For the end behavior, I'm going to look at the degree. In the degree for your numerator, do you guys see any variables up here? No, so we're going to put 0. Your degree for your denominator, okay, think about it. I know I have, oh, well, this is a multiplicity of 1 and this is a multiplicity of 1. That's great, but you need to think about what happens when you FOIL that out. if you were to FOIL this out, what would be the highest exponent you get? A 2. It would literally just be this guy here, x squared minus x minus 6. So when you FOIL this out, your highest exponent will be a 2. What I also tell my students to kind of help them is if you add this multiplicity with this multiplicity, it should give you the degree that you're going to need for your denominator. It should work. I don't think I've had an instance where it doesn't, so I'll let you guys know for sure in the next couple days if it's not going to work, but I think it'll work every time. That means that this is bottom heavy, which means our horizontal asymptote is y equals 0. And then the last part, we can just use the simplified version to find our y-intercept, which will be 3 over 0 minus 3 times 0 plus 2. Even though Nicholas gave us the multiplicity on each of those binomials, we don't have to put them to find your y-intercept. So we're just going to have negative 3 and 2. Well, negative 3 times 2 is just negative 6. And negative 3 over 2, correct me if I'm wrong, that's negative 1/2, right? Okay, good. Let's start to graph. Okay, so I'm going to start with my lack of x-intercepts. There's no roots, that's fine. I have 2 vertical asymptotes. I have one at positive 1, 2, 3, which is apart. And I have another at x equals negative 2, which is also, I'm going to write it up here, apart, because I ran out of space at the bottom. I have a horizontal asymptote at y equals 0. Don't graph this just yet. Look up for just a second. And I have a y-intercept at negative 1/2. So at negative 1/2, I'm just going to graph this down here. Here's negative 1/2. For y equals 0, which is your end behavior, guys, end behaviors only affect the ends of your graph. If you look at every end behavior question I've done with all of you guys, end behavior really just affects the ends. What's happening is the graph continues to move to the right or continues to move to the left. So when you graph the end behavior portion here, do not graph it in the middle, because the middle of your graph is not the end. It's literally the center of your graph. So when you're graphing the end behavior, go on the other side of your vertical asymptotes and create your y equals 0 restriction. Give me a nod or shake. Does that make sense? When I say the end behavior, I'm talking about what is happening at the ends of your graph. That's what I'm talking about for your end behavior. For all of the graphs that we've done so far, have we had more than one vertical asymptote? No. So since we didn't have more than one vertical asymptote, there wasn't a potential issue in the middle part of our graph. This is why I'm having you guys focus on the ends for your end behavior instead of in the middle. If you look in the middle portion of this, there's this point. The issue that I have is I don't know what to draw. There's literally 5 different items I could draw here. Yes, I'm not joking. There's 5 different items. We could make this a linear function where we just draw a line. We could make this a parabola that opens up, or a parabola that opens down, or we could make it a cubic function that starts up here and kind of swivels down here, or a cubic function that starts down here and ends up here. That's literally 5 different options you could have in the middle. For this question, though, there's actually something in the first page of notes that we did the very first day that I starred that I'm pretty sure you guys forgot about. Michelle, can you read this out to me? What does this say? Graphs must what? Read this last part one more time. And can what? So let me ask you this, Michelle. Is there any x-intercepts on this graph? No, there's none. And we double check that here. There's no x-intercepts for our curve here, for our graph. So the great part about this question is, if this is where your point's going to be, what do you think your graph is going to look like here? It's going to be a parabola that opens where? Opens down. You cannot have an x-intercept if it doesn't exist. That won't make sense. So this won't always be that nice and easy. What could I do if I didn't have this kind of logic in my head that, oh, I could just create a parabola going down? Because some of y'all might not have thought of that. What could I do instead? I always tell my students this all the time. If all else fails, plug something in. So what we're going to do, and I'm going to flip this on the backside, at least for me, we're going to use test points. You're going to pick 2 test points, one to the left, one to the right of your y-intercept, and we're going to plug them into our simplified equation to see if we do get a negative value here and a negative value here. I don't care about the exact number, guys. I just care about the sign. Is it positive, showing that it's going to go up, or is it negative, showing it's going to go down? So if our y-intercept is here, what's a good x value to pick on the left? -1. And what about on the right? +1. Let's just use both of those. So let me recopy this on the back side of our page. So we're going to have y equals, we had, look at my problem, 3 over x minus 3 and x plus 2. And we're going to check the 2 points x equals 1 and x equals -1. We're checking both of those. Let me show you what I mean. Okay, we're going to have y equals 3 over, I'm going to plug in the 1, minus 3, and 1 plus 2. I don't care about the exact number. I just care about the sign. So just looking at the sign up here, is this 3 positive or negative? Positive. Okay, so in your numerator, let me rewrite my fraction. I'm going to put a big plus sign. It's positive up here. In the denominator, I don't care about the exact number. I just care about the sign. 1 minus 3 will give you what sign? Negative. It's specifically -2, but this will give me a negative. And we're going to multiply that by the second one. 1 plus 2 is going to give you a what? Positive, specifically +3. In the denominator, if I ask you to simplify, what would you do with these two signs? This is in one parentheses, this is in another. What would you do with them? Multiply. So what's a negative times a positive? Right now, you have a positive divided by a negative. What's a positive divided by a negative? Just negative. So double check. That's a negative symbol. At x equals 1, let me flip the graph back over. At x equals +1, did we draw this going in a negative direction? Yeah, that's what we needed. Let's check x equals -1. All of the steps that I'm doing, you're about to do on your own for question number 9. So we're going to make this -1 minus 3, -1 plus 2. I don't care about the exact value, I just care about the sign. Looking in your numerator, Desiree, is this 3 positive or negative? Positive, so we're going to divide that by. Down here, we're going to have 2 parentheses. -1 minus 3 is what? Okay, so I'm going to put a big negative symbol here. And in the second parentheses, -1 plus 2 is what? Positive. Okay, so in the denominator, if I had both of these symbols in parentheses, I'd have to multiply them. What's a negative times a positive? Negative. And divided by negative. So what's a positive divided by a negative? Negative. All of these circles I'm drawing around it, you don't have to draw the circle around the sign. I just want you to see that it's just a positive symbol and a negative symbol. Same thing here. Positive symbol, negative symbol. All right, so let's double check. Where the -1 is, this graph needs to go down in a negative direction. So I'm going to go ahead and look at my graph. This is at -1. It does go down. That's perfect. That's exactly what you should have. All right, last thing that we need to do is talk about the aparts, because if you look at the whole thing, you're going to mess it up. Let's start on the right-hand side. Ignore the left. I purposely covered it up with my hand. On the right-hand side, Mia, if this is going to be a part, I know I need to graph it across the vertical asymptote in this first area or the second area. Where is the other part of the graph going to be? In area 1 or area 2? Area 1. We're just going to graph this apart going in this direction. We're going to do the same thing on the other side. Okay, so now ignoring the stuff that Mia just did on the right, we're going to focus on the left. Mia, if this part is going down, are we going to draw the other part of the graph in area 1 or area 2? Area 1. This is your complete graph, guys. The fact that I'm actually covering up the different sides, I do it whenever I'm making my own keys and whenever I'm doing the notes and everything. Make sure you actually do that as well. Even though for this question, I'm not going to label the end behavior with you, you should still understand how to do it. X goes to infinity, f of x will go to something else. X will go to -infinity, f of x will go to something else. Actually, since I already wrote it out, let's just do it. Alex, as x approaches infinity, where's f of x going to approach? 0. You're looking at this side. As it keeps going to the right, this blue curve is going to continue going to the right as well, and it's going to keep going right above 0. What about on the left? As x approaches -infinity, where's that blue curve going? 0 again. Right now, I want you guys using that logic that I just talked about, especially with your end behavior, guys. End behavior only affects the ends of your graph. So if you have more than one vertical asymptote, draw your end behavior only on the far left and far right of your graph. With that stuff in mind, I want you guys right now to do question number 9. All I want to do in the next 3 or 4 minutes is just post up what the graph should look like. That's all. I will give you a big hint here, guys. If you don't use the test points that we just did on the back side of this page, you are not going to get a pretty graph, at least not one that's correct. So for question 9, make sure you use a test point. All right, so let's go ahead and look at this. I'll go through it just to make sure you guys understand what to do. So first thing we need to look at is your root. From here, you probably should have seen if you could factor this, which it could be factored for your denominator. So y is going to equal x minus 1 over x plus 5 and x minus 2. That's what I got. So you should have a root at x equals 1. That's your x-intercept, yes or no? You should have a vertical asymptote. Specifically, you should have 2. One at negative 5 and the other at positive 2. Those are your 2 vertical asymptotes. Give me a nod or shake. Am I still on a good track? Okay, the next one for your tangent. What are the multiplicities on both of these? 1. If they're not being put together and being squared, like that first question for number 7 at the top of the page, don't try to square them. So I'm going to say my multiplicity is 1 for both of them, which means I'm going to graph them both apart. E is your end behavior. What's the degree for this numerator? Your degree is just 1. And then for your degree for your denominator, if you were to FOIL both of these, you should get an x squared, which means that your degree for your denominator would be a 2. All I need to do now is just label this as bottom heavy, and your horizontal asymptote will be y equals 0. The last thing I need is my y-intercept. Your y-intercept should just be 1 over 10. And this is the y-intercept. So make sure I label that as y-intercept, guys, so that way you don't get confused. Okay, let's graph what we have. At positive 1, we have an x-intercept. At positive 2, we have a vertical asymptote. And I'm going to label apart. I'm checking everything off, but I haven't finished it. At negative 5, we have another vertical asymptote, and this is apart. Okay, I graphed that. End behavior only affects the far ends of your graph. So guys, you see what's happening in the middle? Don't graph your end behavior in the middle. Graph it on this side and this side only. Do not graph it in the middle, because that's going to restrict part of your graph if you do that. And then positive 1 over 10, here's 1. 1 over 10 will be somewhere here. Okay, so this one is going to give us a couple different options. We can either have a cubic function that's going to cross through this at these 2 points, or it'll be a cubic, or square root, or not square root, goodness, a parabola where it will literally just bounce off of the x-axis and shoot right back up. Those are literally the only 2 options you have. So let's see which one you're going to get. If you use a test point, let's use x equals negative 1, and let's use x equals, okay, well, if you have positive 1 and you have positive 2, what point's in between them? What's points in between? 1.5. So 1.5, since it's a little bit bigger than 1. All you're going to do from here is identify your y values. That's all you're doing. So we're going to take in the simplified, let me box my simplified. In the simplified formula, we're going to take negative 1 minus 1 over negative 1 plus 5 and negative 1 minus 2. This is why I do this on the back side of the page, guys, because I'm running out of space. Either way, we're going to go ahead and simplify. Negative minus negative is going to give you a negative in your numerator. We're going to divide that by the product of negative 1 plus 5 is positive 4, so that's a positive. And we're going to multiply that by negative 1 minus 2, which is another negative. Okay, well, let me simplify this. This will be a negative divided by positive times negative is just a negative. Well, negative divided by a negative, It's just going to be a positive symbol. So I had a student ask me this earlier. Since this is at -1 and we know that it should be going probably up, can we just assume that this graph is going to go up this way? Remember, this isn't going to cross the asymptote, but it's going to get close to it. I'm going to refer your attention back to the notes that we have here. Graphs must pass through any roots on your graph and cannot cross the x-axis anywhere else. So, especially since this graph here is having these 2 points, if I wanted this to go right back down, it would need to have another x-intercept somewhere here. Since I don't see another x-intercept, you really don't need to do a test point to the left, but it is helpful to help you get in that procedure of making sure that you test 2 sides of your graph. So, when you have x equals -1, any negative really, it's going to give you a positive y value. Let's check the 1.5 and see what that's going to do. So for 1.5, let me rewrite what I have. We'll have 1.5 minus 1 over 1.5 plus 5 and 1.5 minus 2. I don't care about the exact numbers, I just care about the sign. So y is going to equal, in the numerator, we're going to subtract 1.5 minus 1 will give you a positive 0.5. I'm going to divide that by, let me put my 2 parentheses. 1.5 plus 5 is going to be 6.5, that's positive. And then 1.5 minus 2 is going to give you a negative. Okay, well, let's think about this. In your numerator, you're going to have a positive, that's going to stay. But a positive times a negative is just negative. Positive divided by a negative, y is going to equal just a negative answer. Sorry, separating the 2 x's that we checked. So down here for my graph, okay, I'm at my point. 1.5 is somewhere here. This part at 1.5 should be going down. It should give you a negative answer. So it should be approaching the asymptote on the right-hand side, and it should be getting very close to that vertical asymptote. This test point, guys, is extremely crucial, and it's super helpful with helping you get the correct answer every single time. Once we have that, we're going to go ahead and check. Okay, well, on the right-hand side, we have this asymptote that's here. It's going down. If we're going to make this apart, we're going to make it apart going in this direction. Oops. Remember, guys, this is approaching the asymptote. It's not crossing through it. On the left-hand side, just take a second and observe. Okay, this part is going up towards that asymptote. If we're graphing apart, we don't want it to go up as well. We need it to go down. And then down that way. So this is our entire graph. This is the whole thing. For questions like this, you definitely want to make sure that you put in some practice with how you're going to get your answers. Make sure that when you're looking at the end behavior specifically, let me check off my y-intercept. Forgot to check that off. But whenever you're looking at your end behavior, make sure you focus on the far sides of both of your asymptotes. The end behavior really only affects the far ends of your graphs. It doesn't affect anything in this middle portion here. All right, the last thing I'm going to write is my end behavior. Since we've already done that for every question, let's just continue. As x approaches infinity, y, which is the same thing as f of x, y should be approaching 0. It's going to get closer and closer. And then as x approaches negative infinity, y is going to approach, let me start on this side, negative infinity. This is going to get closer and closer to 0. That would be your end behavior. Take a second to look at it. Do you guys have any questions? If so, let me know.